Now on to the practice problems. So we're asked for the total number of neutrons in the nucleus of a neutral atom with 19 electrons and a mass number of 39. So if we have 19 electrons, we recall that electrons have a negative charge. So we'll have to have some protons. So we must have the same number of protons. So here we'll have 19 protons and 19 electrons. But what we're looking for is we're looking for neutrons. Neutrons are found in the mass number. Recall that the mass number is protons plus neutrons. So we have 39 protons plus neutrons, and we recall that we have 19 protons because it's a neutral atom. So if we want to find the neutrons, here we'll simply subtract these two numbers. 19 from 39 is 20. Next, we're asked to describe the atom. Recall that an atom has a positive nucleus, so we're going to eliminate choices C and D. So recall that we can go and we have the positive nucleus and it's surrounded by a negative cloud of electrons. So choice B would be our best choice. In the next question, we're asked to compare protons and electrons. So recall that a proton has a mass of 1 and a charge of positive 1, while electron has a negligible mass, so we'll say a mass of 0 and a negative 1 charge. So we can see that they have different masses and different charges. The atomic mass of an element is the weighted average masses of all the naturally occurring isotopes. This is a simple definition. You'll find it in the major understandings. We're looking for the total number of electrons found in an atom of sulfur. The word atom implies neutrality, meaning the same number of protons and electrons. We can find out more about sulfur by looking at our reference table. On our reference table, we can find the electron configuration of sulfur. Recall that those are dashes and not minus signs, so the total number of electrons is 2 plus 8 plus 6, or 16. We can also remember that, again, atoms are neutral, so their protons, their atomic number, equal their electrons. In the next example, we're asked to find out which electron configuration matches that of the excited state. The first thing you'll want to do here is sum up all of the electrons so we can find out which atoms we are looking at. Now we'll go to the reference table and pull up all of these elements according to their atomic number. So here we have sodium, arsenic, sulfur, and arsenic. So when we look at a reference table, we'll notice that the electron configuration of sodium, 281, exactly matches the choice given. All reference table electron configurations are ground state, but in this case we're looking for the excited state. So choice number 1 is not excited. In choice number 2, we have arsenic, which has an atomic number of 33. We notice that the electron configuration on the reference table does not match the electron configuration given in choice B. So choice B is our likely answer, but we want to check the other choices. Choice C, we are given sulfur. Sulfur's electron configuration on the reference table is 286, so that is the ground state. And lastly, arsenic. Here we have arsenic again, but this time the electron configuration of the periodic table exactly matches. So again, this is the ground state. So choice B is our excited state because it has the same number of electrons, but a different configuration than our periodic table. In the next question, we're asked to look at the nucleus of cobalt-58. So recall that in a nucleus we have protons and neutrons. So let's look up cobalt on our reference table. So as we start with cobalt-58, we can see that it has 27 protons because its atomic number is 27. So that eliminates choice C and D. Now to calculate the number of neutrons, we're simply going to subtract 58 from 27. So here, our number of neutrons is going to equal 31. The next question asks about when an electron moves from the ground state to the excited state. So to move from the ground state to the excited state, they have to move from a lower energy level to a higher energy level when they gain energy. So you have to gain energy to become excited, and you're moving to a higher energy level. The next question asks which subatomic particle. So whenever you see the word subatomic particle, you automatically should think proton, neutron, or electron. And we want to know which one is attracted to positively charged objects. Recall that opposites attract. So if it's attracted to positive, it must have a negative charge. And we know that electrons have negative charges. The question number 10 asks about some recall of the Rutherford experiment. Notice that the Rutherford experiment is very important in this unit. So we know that the atom is mostly empty space because most of the alpha particles went straight through the gold foil. And we know that some of the alpha particles, which have positive charges, were deflected by the nucleus. So that means that the nucleus must have the same charge because like charges repel. So choice A is our best choice. Question 11, they ask which have approximately the same mass. We know that protons and neutrons have a mass of 1, and electrons have almost no mass. So we can eliminate any choices with electrons in them. Choice D has neutron and positron, while choice A has proton and neutron. We've not yet learned about the positron. We'll learn more about that in nuclear chemistry. It's basically a particle similar to an electron that has no mass but has a positive charge. It's a positive electron. So we can automatically also eliminate choice D. So choice A is our best choice. In the next choice, we're going to look for electrons in the excited state. So the key term here is excited state. What we'll want to do is we'll want to sum together the electrons. So in choice A we have 6 electrons, in choice B we have 11, choice C we have 8, and choice D we have 12. We're going to compare these electron configurations to the ones on the periodic table. So here we have carbon, sodium, oxygen, and magnesium. When looking at the carbon, we can see that their electron configurations exactly match. So carbon is not the correct choice. Looking at sodium, we can see that sodium usually has an electron configuration of 281, but we're given an electron configuration of 271. We know that this is sodium because the sum of the electrons, 11, equals the atomic number. But it must be in the excited state because it's not exactly matching the electron configuration given on the periodic table. And again, we can double check that oxygen exactly matches, is not excited, and magnesium exactly matches and is not excited. In the next question, it asks us to compare fluorine 19 and carbon 12 in terms of neutrons and valence electrons. So here I've added fluorine to the carbon that we used in the last question from the reference table. So recall that to calculate the number of neutrons, what we're going to do is we're going to simply subtract. So fluorine 19 has 19 minus 9, or 10 neutrons, while carbon 12 has 12 minus 6, or 6 neutrons. Next, we're going to look at valence electrons. Recall that valence electrons are electrons found in the outermost, highest principal energy level. So carbon's valence electrons are going to be 4. We can see that here in our periodic table. And fluorine's valence electrons are going to be 7. So all of our answer choices have the value of 3. So we see that the neutrons are different by a value of 4. So we must not have to worry about neutrons. So here we're going to look at valence electrons. And here it says we're referring to carbon. So carbon has 3 fewer valence electrons. The next question is a simple definition of isotopes. So isotopes always have different masses, same atomic number. Now, we know that atomic number is essentially the same thing as the number of protons. Now, if something has a different number of electrons, then we're actually going to call it an ion, not an isotope. In the next question, please note that the word plus in the answer choices indicates the mathematical operation and does not indicate the word and. So in this case, we're looking for the atomic number. Recall that the atomic number is always equal to the number of protons. Again, we continue to move forward with definitions. So here we're looking for the subatomic particle, proton, neutron, or electron. That means we can get rid of alpha particle, we can get rid of beta particle. Subatomic particle has no charge, and no charge is for the neutron. So when electrons in the excited atom return to a lower energy level, the electron emitted can result in the production of spectra. This is again a simple definition. As is the region of probable location of an electron, we call this an orbital. Next, we're asked to look at the nucleus of a potassium-42. So let's pull up potassium from our reference table. So here we see that potassium-42 has 19 protons. So we can eliminate choices C and D. And since the mass number is 42, to calculate the neutron number, we're simply going to subtract 19 from 42. And 19 from 42 is 23, so our best choice is choice A. Lastly, we're asked which particles are found in the nucleus. We know that in the nucleus we have protons and neutrons. Electrons are only found outside the nucleus in the electron cloud. So any choice with electrons cannot be it. And we know that we also have protons, so choice D is the best choice. Next, we're looking for the valence electrons of an atom of sulfur in the ground state. So we're simply going to have to pull up sulfur from our reference table. So here, the key word is valence electrons. We can see the electron configuration of sulfur here has 16 electrons, but the valence electrons are just the outermost electrons. So there are 6 outermost electrons in sulfur. The charge of an electron, we know, has a charge which is negative, and an electron have almost no mass. The next question is asking us for the correct Lewis dot structure. When examining Lewis dot structure, we know that the number of dots have to equal the number of valence electrons. So let's pull up these atoms from our reference table. So here we have nitrogen, fluorine, oxygen, and neon. And recall that the valence electrons are the electrons that are in the outermost principal energy level, or to the very right of the electron configuration. Nitrogen should have 5 dots because it has a valence of 5. So this nitrogen only has 4 dots. It's incorrect. Fluorine should have 7 dots. This fluorine has 8 dots. That is not correct. Oxygen should have 6 dots. This oxygen has 7 dots. And neon should have 8 dots. This neon has 8 dots. This is the correct Lewis structure. In the next question, we are asked to find the number of neutrons. And we're given a mass number, recall that mass number is neutrons plus protons, of 19, and an atomic number, which is the same as the number of protons, of 9. So to calculate neutrons, we will subtract the atomic number from the mass number to get 10. The last question asks us about the charges of the electron and the proton. We know that the electrons are negative and the protons are positive.